We have already seen how to add fractions, and today we're going to look at adding fractions that also include mixed numbers. So where you have a whole number and a fraction together. Okay, we'll have a quick recap. We'll have a quick look at how we add the basic fractions that we have been doing so far, and then we will move on to how we would add fractions that include mixed numbers. Okay, so the first question here, the first example, as you can see, is 2/15 plus 4/15. And this is an easy one, as we can see, because the denominators are already the same. We notice they're both 15, so if I have 2 pieces of a cake which has 15 pieces, and then I eat another 4 pieces of that cake which had 15 pieces, that means altogether I ate 2 and 4, 6 pieces of the cake which had 15 pieces. So I ate 6/15 of the cake. Do you remember that we always look at our answer and check if we can simplify? Right, we look at the answer, we notice that both 6 and 15 divide by 3. So if I divide the 6 by 3, I will get 2. If I divide the 15 by 3, I will get 5. So my answer here is 2/15, 2/5 even. Right, so 2/5 is my answer. Let's move on to question 2. Okay, so this second example, we can see we're trying to add 2/3 and 1/5, which is not so pleasant as the previous one, because we notice that the denominators are not the same, and in order to add the fractions, the denominators need to be the same. Do you remember what we said about the denominators? The lowest common denominator can never be smaller than the biggest one. Okay, so the lowest common denominator will be 5 or more. Does 3 go into 5? No, it doesn't. So 5 is not the lowest common denominator. So we will keep saying the 5 times table until we find a number that 3 also goes into. So 1 times 5 is 5. 3 does not go into that. 2 times 5 is 10. 3 does not go into that. 3 times 5 is 15. Obviously, 3 goes into 15 because 15 is made up of both 3 and 5. So 15 is my lowest common denominator. Then we think, how many times does 3 go into 15? 3 goes into 15 5 times, because 3 times 5 is 15. Whatever I did to the numerator to get it to 15, I will do to the, whatever I did to the denominator to get it to 15, I multiplied by 5, I will do to the numerator as well. So 5 times 2 is 10. I then look at this 5 here. What do I multiply 5 by to get to 15? I multiplied it by 3. I multiply the numerator by 3. 3 times 1 is 3. I add those together. Now that the denominators are both the same, I add the 10 and the 3, so my answer is 13/15. Does it simplify? No, it doesn't. Okay, let's do one more example. This one here has 3 different fractions. The biggest denominator is this 15. Does the 5 go into the 15? Yes, it does. That's good. We can ignore the 5, that means. Does 10 go into 15? No, it doesn't. So let's think of multiples of 15 that 10 might go into. So we said 1 times 15 is 15. 5 goes into that, but 10 does not, so I'm not going to use that. 2 times 15 is 30. 5 must go into that anyway. We don't even have to think about the 5 anymore because it will go into all multiples of 15 anyway. But let's look at the 10. Does 10 go into 30? Yes, it does. We're happy. We're going to use that 30. So we'll say 30 for each of those. We've already done this in class many times. Right, now let's think about it. How many 15s make 30? 2 15s make 30. How many 10s make 30? 3 10s make 30. How many 5s make 30? 6 5s make 30. And now we can go ahead and multiply our numerators. 2 times 2 is 4. 3 times 1 is 3. 6 times 2 is 12. Now we're ready to add the numerators. 4 plus 3 is 7. 7 plus 12 is 19. So this is 19 thirtieths. Is there a number that they both divide by? 19 and 30? No, there isn't. That's my final answer. Right, let's move on. Okay, let's actually add fractions that include mixed numbers. So let's introduce adding fractions involving mixed numbers. Here we have another question which involves, this time, a mixed number. That 2 and 1/5 is a mixed number. If I need to add 2 and 1/5 to 2/5, I have to think about this in terms of this is 2 whole cakes and 1/5 of a cake. And we want to add that to 2/5 of a cake, which means I'm going to have 2 whole cakes plus 1/5 and 2/5 makes 3/5. So altogether, I'm going to have 2 and 3/5. Okay, so looking at it this way, without the diagrams, we can't be drawing diagrams every time. We can just say 2 and 1/5 is the same as the 2 cakes plus 1/5 of a cake, plus another 2/5, because we need to add on the 2/5. We say that is 2. I will add these two fractions together. They're lovely because they're the same denominator. 1/5 plus 2/5 gives me 3/5. So that's 2 plus 3/5, which is obviously 2 and 3/5. Not too bad, right? Let's move on. Let's look at another example here. 2 and 1/3 plus 3 1/4. This involves fractions here, or mixed numbers that do not have the same denominator. But let's just look at them diagrammatically first. We have 2 cakes and 1/3 of a cake, plus 3 cakes and 1/4 of a cake. So that's 2 and 1/3 plus 3 1/4. How many cakes do I have altogether? I have 2 whole cakes and another 3 cakes, which makes 5 cakes. So I'm going to add those two to make my 5 cakes. And here I have 1/3 of a cake plus 1/4 of a cake. Now let's look at that in a form where we're writing rather than drawing diagrams. So we have 2 whole cakes and another 3 whole cakes. So I can just add those together from the start if I like. I can say that's 2 plus 3 whole cakes. And then I have this 1/3 and this 1/4 to add to also. So we have 2 plus 3, which is 5, plus 1/3 and 1/4. Now we need to make these the same denominator. What did we say when the numbers are very close in the denominators? We said the lowest common denominator will be just those two multiplied together, the product of 3 and 4. So this is 5 plus the product of 3 and 4 is 12. We'll make them both into 12s. What did I multiply the 3 by to get a 12? I multiplied it by 4. What did I multiply the 4 by to get a 12? I multiplied it by 3. So I multiply the numerators by 4 and 3. 4 times 1 is 4. 3 times 1 is 3. So that equals 5 plus 4 twelfths plus 3 twelfths is 7 twelfths. So my final answer is 5 plus 7 twelfths is 5 cakes and 7 twelfths of a cake. Right, so that's that question done. Let's look at question 3 now. We have 3 different mixed numbers to add together. Let's add all those numbers at the front together. Maybe we can just do them in one go without saying 3 plus 2 plus 5. 3 plus 2 plus 5 is 10. 3, 2, 5. That makes 10. Plus a half, plus 3/8 plus 1/4. Add them all in. That's 10 plus, we need to find the lowest common denominator. The highest denominator is 8. Does 2 go into 8? Yes, it does. Does 4 go into 8? Yes, it does. So that makes it quite kind of easy for us. We know that the new denominator will be 8. We can actually put them all under 1 instead of putting them separately. Like in this one, we put them all separately, didn't we? We just made them 12, so we wrote them separately. If you like, you can actually put them all in one like this. Okay, so we will say 2 goes into 8 4 times. So I'm going to put a 4 here. 8 goes into 8. Well, it's already 8, so I'll just say it goes once. And 4 goes into 8 twice. Now we multiply. 4 times 1 is 4, plus 1 times 3 is 3, plus 2 times 1 is 2. Which equals, we have our 10 from here, plus 4 plus 3 plus 2 makes 9. 9/8. Red alert. What do we notice about this? The top is bigger than the bottom. That's an improper fraction. We need to convert that into a mixed number. We did that over last week, was it? Or beginning of this week? Let's convert that 9 and 1/8. What is 9 and 1/8 as a mixed number? Let's think. 8 goes into 9 once, or 9 divided by 8 is 1. Remainder 1. Yes? So if I convert that into a mixed number, that's going to be, this is my 10, plus, that's going to be, it goes once, and my remainder 1 is here, is going to go on the top. So we should know by now how to do this, because I think we've had practice. What we should have. I can't get the lid off my pen. There we are. Okay. 1 and 1/8. Remember, the denominator stays the same. Okay, so 9/8 is 1 and 1/8. Okay, so that remainder 1 here is here. Okay, so 10 plus 1 and 1/8 will be 11 and 1/8. Okay, let's move on. 2 1/2 plus 4 3/4 plus 1 1/6. 2 plus 4 plus 1. 7. Plus 1/2 plus 3/4 plus 1/6. The biggest denominator here is this 6. Does 2 go into 6? Yes, it does. Does 4 go into 6 exactly? No, it doesn't. Let's say our 6 times table until we find a number that 4 also goes into. So 1 times 6 is 6. 4 doesn't go. 2 times 6 is 12. Does 4 go? Yes, it does. It divides by 4, so we're happy. Right, so let's make these all into 12ths. So we have that 7 in the front, and we're going to make these all into 12ths. You can do them separately, or you can do them as one denominator like we did up here. Okay, so 2 goes into 12 6 times, 4 goes into 12 3 times, 6 goes into 12 twice. Now let's multiply these. So 6 times 1 is 6, 3 times 3 is 9, 2 times 1 is 2. So that equals 7 plus 6 plus 9 plus 2. 9 and 6 make 15, and another 2 makes 17 twelfths. which equals 7 plus, this is an improper fraction, 12 goes into 17 once. And we have a remainder of 5. So 5 left over, 5/12. So my final answer on this is 7 and 1, which is 8. I'll just write it over here because it's 8 and 5/12 is my final answer. Okay, I want you to try and practice these. Page 109, questions 1 to 24. All right, and if you're enjoying yourself, maybe you can go on and do the written problem type questions, which is 25 to 29. Now, if you feel you're working very slowly, you can do 1 to 24, the evens, and then maybe tomorrow or another day, do the odds. Basically, the more practice you get, the better it is for you. You have to feel comfortable with the fractions. You don't want to be afraid of them. So I don't want you to spend hours on them, but I want you to sit for at least half an hour every day. And if you actually did half an hour a day until Monday, you could easily get 1 to 24 done, whatever your level or however strong you feel. All right? So speak to you soon, live next time, hopefully. Please have these done for yourself more than anything. Thank you. Bye-bye.